All right, so thanks for having me. It's great to be back. I'm going to be talking about uh, 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 a new path for increasing capabilities of Smallsat technology. So what I'm going to cover today is first I'm going to go through some definitions and then talk about pathways. So what do we mean by pathways? And then I'm going to spend some time looking at markets. I'm going to briefly hit upon technology. And how that plays a role here, some trends and observations, and then finally some conclusions. So first off, what is a small sat? There's no real established definition of small sats. I spent a good bit of time doing research in the area, lots of different definitions, and the two most interesting versions of small sat definitions came from the FAA in the US and Viasat. And I pretty much have aligned my thinking with the Viasat definition of what they call a mini sat. So that's what we're going to call a small sat for the purpose of this discussion. So that's a vehicle that's between 100 and 500 kilograms of mass. It's about the size of a motorcycle, just to put it in context. So the next set of definitions we need to think about are orbits, because we talk about LEO and cislunar space and deep space. So what does all this mean? So again, going to one of my favorite sources, Wikipedia, there was a very good graphic which illustrates LEO, other Earth orbits, which include HEO. What LEO stands for is low Earth orbit, HEO, high Earth orbit, GEO, MEO, and then cislunar is basically covering the space between the Earth and the Moon and the surrounding area. So that's roughly the Moon, as the chart on the right shows, is about nine times further than geostationary orbit. So let's keep these definitions in mind. So next we're going to talk about pathways. So pathways define the capability that the evolution of small sats will occur. And when you think about pathways, there's lots of different forces and influences on them. So when I look at pathways and I think about how they impact the small sat market and small sat business, the market forces, which are what are the markets, what are the market demands, which markets are growing, which are shrinking, what's the technology base. But also there are other important topics here that I don't have time to cover today. Manufacturing and supply chain, those are really critical. And finally, capital availability. One of my favorite movie quotes from The Right Stuff is, "No bucks, no Buck Rogers." So if there's no capital available, all these other things can be aligned positively, and you won't be able to make progress. So the other point I'm going to make with regards to pathways is that progress is likely to be incremental. And I'm giving a little bit of a hint of a topic I'm going to spend a good bit of time talking about later. And that's quite what I expect to happen, and what's already been happening in the small sat market is progress is made by exploring market adjacencies. Market adjacencies are markets that if you have a product, and an adjacent market is a market that's close by to the market that you're already serving. So I'm going to go to the next slide. So if we look at the market, I think it's pretty well known, but I just wanted to establish this point of clarification here, that the small sat sector is, and this is for a recent study from Euroconsult, the small sat sector is in the midst of a hockey stick-like ramp up in deployments. Over the next decade, Euroconsult projects an average of 1,700 satellites to be launched each year through going into 2031. And that's more than 4 times the launch rate of what we've seen in the last decade. So clearly, there's an enormous amount of growth in the small sat market. Next, how do we think about markets? How do we classify them? How do we analyze them? So Seraphim puts out a lot of really interesting and very insightful reports. This is something I've extracted There's a little bit of an eye test in the lower right-hand corner here, but if I blow up one segment into orbital tugs, it lists orbital tugs and it lists a bunch of company logos of companies that were engaged in the orbital tug business in some way, shape, or form. Some have already demonstrated capability, others are emerging. So in the area and according to Seraphim, again, the area that has the most relevance to Smallsats are in-space services and communications. So within in-space services, they talk about orbital tugs, orbital servicing, life extension and refueling, debris removal, and space situational awareness, which is also called space domain awareness. So that's kind of a view, that's sort of a picture of the markets from how Seraphim looks at it. Bryce has another kind of market projection here, and they recently put out a report, and they were looking basically at satellites that were launched in the third quarter of 2022. And what they saw was that small sats, and I'm defining small sats the way we defined them earlier, 100 to 500 kilograms, it represents about 40% of the total mass launched in space. So this is a significant fraction of the launch activity. So I think, from these 3 slides, we get a pretty good idea that this is a pretty significant amount of business. But I'm going to share with you a view that I find most useful in thinking about markets. To me, markets, sort of almost, you can look at this from like a mathematical perspective. It's sort of like a multi-dimensional space. One dimension's customers, and customers, they're either commercial or government, and I would lump nonprofits in with government. And within government, of course, it's civil and defense, national security, space, and intelligence. Another dimension is the operational environment, and it ranges from VLEO, which is very low Earth orbit, all the way out to cislunar space. Another dimension to the problem is payload size, weight, and power, or SWAP. So I've categorized 3 different size categories for payload: less than 50 kilograms, 50 kilograms to 250, and then larger than 251. And finally, the last dimension in thinking about markets are apps. So there's imaging apps, there's communications, and there's infrastructure. Now, the Seraphim report covers a lot. When they listed infrastructure, they covered a lot of these apps, but there were some also that they didn't list, but they were listed in other parts of their taxonomy. But here I included resource utilization, manufacturing, and edge computing and storage. So the point of this, the purpose of looking at markets this way is, I claim that every opportunity can be defined just sort of like you walk into a restaurant with an a la carte menu, 1 from A, 1 from 1, 1 choice from 2, 1 from 3, and 1 from 4. So to illustrate how this works is, let's look at market space here. And of course, I can't show 4 dimensions in PowerPoint. In fact, some could argue my attempt to show even 3 dimensions of PowerPoint here is a little hard to see. So I apologize. But so according to the legend on the right, stuff I show in green is the current market, and stuff I'm showing in blue are emerging. And then there are satellite icons here showing different opportunities or different types of programs. And medium and large satellites are represented by a larger icon with a red outline. Small sats are in blue, and microsats, smaller satellites, are much smaller with yellow. So we look over here, we see there's a blue square over here in LEO, in the commercial market sector, that's doing passive imaging. And companies that are in that business right now are Black Sky, one of the 2 owners of LEO Stella, Maxar and Planet are examples. Right next to them, but they're using smaller satellites, microsats, are Capella and ICEYE. and they're doing active imaging, radar imaging. And then so in a sense, this is an adjacency, but it's an adjacency based on size of the platform. And then Starlink, OneWeb, and Kuiper, which is an emerging small satellite communications architecture. These guys, they're in the commercial sector. Actually, this is placed in the wrong spot. Should be where communications, the communications apps, and they're also in LEO. So up here, we see commercial GeoCommSats, and they're shown up in GEO, of course. These are commercial, but also civil, because there are some governmental CommSats as well, and they're doing communications. And then we see some other opportunities here in the military side, SDA tracking layer and transport layer, and GPS over here as well. So these are all larger satellites. So this gives you an idea of market space. But one of the things you can see from looking here is, and this is by no means trying to represent all of the market space that's currently being consumed, but if you're in one area of business, whether you're a satellite operator and how you have an app that you're running, like communications or imaging, or if you're a payload or a satellite manufacturer and you're supplying these parts, when you provide a service and you've got a business going, you're sitting somewhere in this market space. Next, I briefly want to talk about technology. And again, what I did not want to do was to dive deeply into Smallsat technology. You could have a whole session on Smallsat technology. I just wanted to call the folks that are watching this talk their attention to a great report that NASA puts out every year. It's called the Smallsat Technology State-of-the-Art Report. Here's the cover of the most recent version. I think this was released in 2023. And I just pulled out a really interesting graphic, which shows typical small satellite in-space propulsion trades of thrust versus specific impulse. There's a wealth of information here. And clearly, if you're in the Smallsat business, a document like this is a great resource. But also, if you're an operator or you run an app, being knowledgeable about where the state of the art is really essential in setting up your business. So now I'm going to talk a little bit about trends and observations from in terms of both customers and the market. So the volume of market space served by Smallsats is continuing to expand, and this is because Smallsat capabilities are expanding. So that's enabling more business cases to close. And if I think about it, if you look back in time, I would argue that one of the reasons that P-LEO constellations have emerged and the Smallsat business has exploded has largely been because of two factors: the emergence of low-cost launch, which most people attribute to the rise of SpaceX's Falcon 9 offering, and then the reaction of all the other launch companies, the ones that are still in business or emerging, to try to meet those price points, but also the emergence of extremely sophisticated technology, like what we find in our smartphones, because a lot of that technology, especially software and avionics, a lot of that technology has found its way into the Smallsat platform. So when we see these capabilities of the Smallsat platform expand, this has resulted in more business cases closing. The other thing that we're seeing in terms of a trend is the emergence of service models versus conventional acquisition approaches. So what do I mean by service models? By that I mean, and this is especially true in some areas in the government, where instead of the government putting out an acquisition saying, I want to buy a constellation that's going to give me imagery, you're going to deliver the satellites to me, I'm going to have a mission operations center, I'm going to launch these satellites, I'm going to operate them. That's been the way most operators or customers have worked in the past. Service solutions are, for example, like Planet and Black Sky and Maxar. They're selling images to governments and other customers, and they make the investments to create these service offerings, these constellations. So the benefits to the customer is that solutions are almost always delivered much more rapidly and almost always at lower cost. Now you would say, well, why isn't this taking off? This sort of like taking over the preferred way of doing businesses. And I would claim that the barriers to adoption for this are often cultural within the customer. Customer has, for example, the customer has a big organization that exists for running a ground station or for integrating payloads on satellites or whatever. And the customer decides there's a lot of importance for keeping that organization around and supporting them. So this is a cultural reason why service offerings aren't always adopted. So another big trend here is that there's increasing use by the government on small sats to achieve their missions, and this is really to accomplish new missions like mesh networks or higher refresh rate Earth observations. Example of mesh networks we'll see, I think later this year, the Space Development Agency will be launching the first parts of Tranche 0, I think, of the transport layer. We'll see, of course, Starlink and OneWeb are doing it on the commercial side, but SDA's transport layer is a governmental mesh network, and also high refresh rate Earth observations with small sats on platforms and in low Earth orbit, large enough constellation. The same area can be observed, with minutes, where refresh rates are in minutes, not in hours. But also another important feature here is governments are using small sats to augment their existing missions. They have larger satellites performing missions, and they're looking at what are known as hybrid constellations, where there's an offering where they're looking at taking small sats and integrating the small sats into a program that they already have that's performing a mission. Now, the benefits that governments see in using small sats are increased resilience, lower development and operations costs. But another one that's also frequently overlooked is the opportunity to infuse new technology when you're doing refreshes. And I want to get back to an earlier point. When we look at increased resilience, I think the response of attempts to jam Starlink, and then Starlink's ability to get around the jamming through a software update, and for Starlink to provide Ukraine reliable, resilient communications after Russia's invasion, has demonstrated the resiliency benefit that proliferated LEO constellations can provide, but not just for reliable communications, but for other apps as well. There's another point here that I think is a really important point to understand, and that there has existed an extremely highly synergistic relationship in the US between the Space Development Agency and commercial satellite manufacturers. So at the very beginning, when SDA was started, their mission was to put satellites up quickly, short schedules, put stuff on orbit, and they wanted to leverage existing and emerging commercial capabilities. That's happening. Commercial manufacturers, some started up with their first major customer being SDA, creating small sats. SDA didn't just design a constellation based on existing capabilities. They kind of moved the bar out slightly, and they challenged commercial small sat manufacturers to produce small sats at higher level of performance. larger payload swaps were needed. The manufacturers have responded. These all, whether we're talking at transport layer or tracking layer, there are hundreds of satellites currently being manufactured and being prepared for launch over the next several years. As a result of these larger swap Smallsat offerings, commercial operators are now starting to leverage these more capable Smallsat platforms to enhance their products and their apps. This in turn is going to cause, I believe, the government to seek even more demanding missions for Smallsats as the government seeks to leverage existing and emerging commercial capabilities. So there's this synergistic relationship between SDA and commercial satellite manufacturers. It's been very interesting to observe. And so another trend that I observe when we look at Smallsat manufacturing is many Smallsat manufacturers started their business building what we call one-offs. They got an order to build a Smallsat for a tech demo, or they started off building CubeSats, much smaller platforms. And many that have moved up into the Smallsat class are finding the leap from CubeSat platforms to manufacturing Smallsat platforms challenging. Others are facing challenges scaling up from one-offs to producing constellations on a schedule that the customer needs, but also just as importantly, that work reliably. I've spoken to customers who have bought small constellations from Smallsat manufacturers, and for some of them, only 10% of the satellites are working reliably. So these are challenges that many Smallsat manufacturers are facing. Also, and everyone's heard a lot about this, there's a lot of challenges in supply chain. It's affected everybody. It started, before the COVID-19 pandemic, and to a certain extent, it still continues today. A lot of customers are under the impression that vertical integration is key. I know when I talk to customers, they'll ask me, share with us, the extent to which LeoStella is vertically integrated. So the comment that I'll make about this, that vertical integration isn't a panacea. If you vertically integrate, it requires you to make large investments to create and maintain all these subsystems and components that you're building in-house. But also, you're moving the supply chain problem. You're not solving it necessarily. You're just moving those problems inside your company. So it doesn't necessarily solve the problem. The real solution for supply chain is to effectively manage the supply chain. Have a lot of insight into your suppliers, how they're doing. And finally, the last thing I'll say is everybody's having a people challenge. And by that, I mean, everyone's having a hard time finding qualified engineers, technicians, software people to help design and build their satellites. So let me dive in here to market adjacencies really quickly. So we'll talk about how they affect pathways. So I'm going to consider three cases. So if you're currently building a LEO remote sensing satellite and you want to move into a market adjacency, which is a LEO mesh comm satellite, that'll be case one. Case two is a LEO remote sensing satellite to a LEO OTV, orbital transfer vehicle. And then finally, a LEO comm satellite to a GEO or cislunar space situational awareness satellite. So let's look at those three cases. First off, some market adjacencies are easier than others, and this will be really clear with these three cases. So for case one, what is it going to take that LEO imaging satellite and turn it into a mesh communication satellite? First, you're going to need a much more sophisticated comms payload, and that would mean that your partner, if you're not building that comms payload in-house, you're going to have to find a partner that really understands this. But the biggest change for you is you're going to need more payload size, weight, and power. Because if your imaging satellite's a passive imaging satellite like an EO IR payload, you can probably get away with 50 to 100 watts. Here you're probably talking about 500 watts or more. So that's going to take a modest investment for you to do that. And that's something that most small sat companies can do. Now, if I want to go from a LEO imaging satellite to an OTV, now this becomes a bit more complicated. You're going to need to be able to provide much more delta V than what a normal imaging satellite needs. You're also probably going to need to be able to provide the ability to refuel, not just the technology, but also a partnership with a propellant depot company. You're going to need an upgraded attitude determination and control system. You're going to need proximity ops software and sensors, and you're going to need robotics. That's going to take a significant investment. And finally, if we talk about case 3, which is the LEO ComSat to assist lunar space situational satellite, you're operating in a completely different radiation environment. You're going to have to rethink all your electronics shielding. You're going to need a different ADCS approach, more delta V, more payload swap, deep space comms and navigation. That's probably a different satellite. That's going to be a major investment. So it's in my view, it's very difficult to take an existing LEO satellite and modify it to fulfill missions in the geo and cislunar space. So some other trends and observations I want to make is launch. In my mind, launch remains the largest bottleneck for the deployment of small sat constellations, as there's ample manufacturing capability. There are additional launch providers that are emerging. It's not clear how many of these will be viable. And I think everybody that I talk to in the business sees the emergence of Starship and New Glenn. They're going to have a huge impact on reducing launch costs. They're also going to stimulate the development of orbital transfer vehicles for last mile delivery. But more importantly, as a satellite manufacturer, it's going to cause both our customers and us to think about how you view risk. Because if you can launch something for 1/10 the price, you might be willing to not value risk as much in the satellite and look for ways to save money. So in conclusion, I want to point out that most market projections show continued growth in the market. There's a lot of space open for business. There's a lot of attractive market adjacencies. Government demand could stimulate some of the more technically challenging adjacencies. And as I pointed out, there's not going from LEO to deep space is not an easy step. So finally, I want to close with a shameless plug for the company where I'm VP of BD, LeoStella. LeoStella is a joint venture between Thales and Alenia Space and Black Sky. We design, manufacture, and deliver small satellites. We started 5 years ago as a clean sheet. There was nothing there. We started with the intention of building small sat constellations. We now have 17 on orbit. We have more than 31 years of cumulative on-orbit experience. We provide, I believe this is #1 in the industry. Our satellites are providing mission availability at greater than 99%. We co-engineer our solutions with our customers. This isn't a cookie cutter business. Everybody's satellite is different. And finally, we can build dozens of satellites per year per customer. So with that, I'll stop. Be happy to answer questions. And I would look forward to follow-up dialogues and discussions with folks as they're interested.